Okay, here we go with some hints for homework 4. The first question, find the roots of the equation. So roots is where you put your formula equal to 0. So 2x squared plus 3x minus 2 is equal to 0. Now this is one which will factorise. So factorise it into two brackets. Put the first bracket equal to 0, which will allow you to work out what x is. Similarly, the second bracket equals 0, which will allow you to work out x. Question 2. Prove the triangle is right angled. Well, it's a converse of Pythagoras question. So the first thing we need to do is we need to take each side and turn and square it. So what is PR squared? What is PQ squared? What is QR squared? Once we've got these three answers, find the two smallest ones, add them together and see if it equals or does not equal the big side squared. If it does, then it's a right angle by the converse of Pythagoras. If it doesn't, then it's not a right angle by the converse of Pythagoras. And remember, you need to put that in your sentence. The converse of Pythagoras. Question 3, factorise fully. First thing we do when we factorise is we look for a common factor. So from the expression above, we've got 36 and 4, so that's going to tell me that 4 is going to be a common factor. So once I've taken 4 as a common factor, that should then allow you to put it in a pair of brackets. Question 4. The speed is 18,000 kilometres per hour. We need to change that all the way down to metres per second. So I've got to change the kilometres into metres, and I've got to change the hours into seconds. So if we go through each stage one at a time, first thing I'll do is I want to change kilometres into metres, so I'm going to times that by 1,000. So it's going to give us a new number of metres per hour. And then how do I change hours into seconds? If I divide by 60, that'll give me metres per minute. And then if I divide by 60 again, that'll give me my final answer in metres per second. Remember, it's non-calculator. Question 5, Question 5, describe the nature of the roots. So that's a discriminant question. And remember, the discriminant is only your b squared minus 4ac part from your quadratic formula. So for the question up the top there, first thing we need to do is we need to work out what's the value for a, what's the value for b, what's the value for c. So a is before the x squared, the b is before the x, and the c is the constant number. Plug all those values in and you'll either get a number which is bigger than 0 for two real distinct roots, equals 0 for repeated roots, or less than 0 for no real roots. Question 6. Calculate the size of the reflex angle. So that's the red angle in my picture here. Now the question is talking about arcs, and the formula for an arc is the angle at the centre, which is alpha, divided by 360 times pi d. So what information do we have for either the arc, the angle or the diameter? There's three variables there. We must know two of them to find the third one. Okay, the question tells us that the arc length is 31.5, so I'm going to put that in for arc. The alpha is what we're trying to find, so I'll leave that. Times pi times, now the diameter of the shape is the distance right across it. Okay, now we know from the picture that the radius is 6.4. So therefore we can work out how much it is straight across, 12.8. Last thing we need to do is we're trying to get alpha on its own. So alpha equals. So in other words, the 360 has to go across, the pi has to go across, and the 12.8 has to go across. Now remember, when they all move, they do the opposite. So the 360 becomes times 360, the pi becomes divide pi, and the 12.8 becomes divide 12.8. Do all that, you should get your final answer for the angle. Question 7. The roots to two decimal places, well, that's a giveaway straight away, that it's one of these negative b's plus or minus square root of b squared minus 4ac divided by 2a. Okay, don't have to say much about that other than remember to put your unrounded answers in first of all before you then round it to two decimal places. Last questions. A wee while since we've done one of these. We've got a bus that's trying to get through that tunnel. The height of the tunnel is the company requires a minimum height of 4.5 metres. Will they be able to use this route of the tunnel? So what we really need to find is how tall is this distance here. Once we can work out that distance there, then we can see if the bus will actually fit through it or not. So what do we know? We've got 2.5 for the radius, we've got 2.4 for the bottom there. Now a little bit of work here, that is the radius, so that's a 2.5. So the next thing we really need to work out is the height of the triangle, because the height of the triangle added to the 2.5, that's going to give you the height of the tunnel, and then you can compare it against what the bus company says you need. So I need to find this distance here. The cat's going to help us. So if we extract the triangle from the diagram, we know that the sloping side or the radius is 2.5, the bottom is going to be 1.2, so a little bit of Pythagoras work is going to tell us the height of the triangle. We're going to add on the other radius, another 2.5, and then we're going to compare that against what the question says. Remember, the answer to this question is not what is x, it's whether or not they will be able to use a route with this tunnel. So answer the question that's been asked. That's us.